All right, I want to show you another example of converting vectors between different representations. So here's a good question here. We have a vector with magnitude 5 meters per second that points 310 degrees counterclockwise from the plus x-axis. What are its components? What I would actually encourage you to do now is pause the video for a second, see if you can scratch out the answer to this on your own, and then you can watch me do it and see if you got it right. To see if you actually understand this topic. But nevertheless, through the magic of video, I can just press onwards and you can watch the video at your own pace. Okay, so first of all, the first thing I want to do in this particular case, they didn't draw the vector for me. They just gave me a verbal description of the vector. So the first thing I want to do is draw it. That's going to be maybe the most important piece of advice for this course in general is draw everything. Draw, 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 draw. Once you draw it and you can see it, it becomes real and it becomes something that you can actually wrap your head around and solve. It's hard to figure out, you know, if you read a word problem and it doesn't quite, like you can't quite see it, like the pieces are all jumbled up in your mind, that's not strange. That's why we draw a picture first, so that you can actually see what you're doing. And then once you see it, you can actually do it. So anyways, I need to draw this thing. So let me draw some coordinate axes first of all. Get my drawing tool. So, okay, here's an X and Y axis. Now, let me look at this angle they gave me here. 310 degrees counterclockwise from the positive X axis. So 310, that means I'm gonna need to go 90, 180, 270, and then even 40 degrees past that. So a 310 degree angle is going to be all the way around like this to the bottom right hand quadrant. So I'm going to have a vector that looks like that with a 40 degree angle here. And again, 40 because 310 minus 270 is 40. Or if you prefer, you might also have drawn it with a 50 degree angle on this side, because 360 minus 310 is 50. Those are both true. Whichever way you draw it is fine. So now I actually have a picture of the vector. I have the angle there, and I know that the magnitude is 5 meters per second. Next thing we need to do, draw the triangle. Turn it into a right triangle. Now, one thing you might notice here, there's actually two possible right triangles you could draw. You could do it this way. You could go down first like that, and then you could go over like that and draw your right triangle that way. And you could also, let's switch colors. Let's do this one in blue. You could have gone to the right first and then gone vertically like that. So there's actually two right triangles you can draw. Let me make this a little bit clearer in case you can't see what I mean. So the red right triangle, it looks like this. It goes down and left, and then we have a hypotenuse like this, and we have a 40 degree angle here. Or the blue right triangle is your other option, where we went over like this, we went down, the hypotenuse is like that, and we had a 50 degree angle here. Okay, and in both cases, the hypotenuse is 5 meters per second, and over here, 5 meters per second. Okay, now I want to say both of these right triangles are fine. Sometimes you might think of it one way easier than the other way. So let me solve it with both of the right triangles and just show you that you get the same answer either way. All right, so let's start with the red one. In the red triangle, we need a name for this vector. This is another velocity vector, so let's call it V. So this will be vector V. So that means this side of the triangle, this is going to be Vx, and this side of the triangle is going to be Vy. I'm basing that on the fact of which side is oriented horizontally and which side is oriented vertically. Now, I can see from the triangle here that Vx is opposite of the 40-degree angle, and Vy is adjacent to the 40-degree angle. So that tells me that Vx is going to be 5 times sine of 40. Again, why did I pick sine there? Because sine equals opposite over hypotenuse, and I can see in the picture that Vx is opposite on the opposite side of the triangle from the 40-degree angle. And then the other one is going to be Vy is 5 times cosine 40, because Vy is touching the 40-degree angle. Vy is adjacent to the 40-degree angle. And if I crunch the numbers on this, I get Vx is 3.2 and Vy, I got 3.8. All right, one last thing I have to do. I have not checked the signs yet. When you use this method to determine the components, you have to put in any negative signs yourself because they will not come out naturally. So now I need to just take one last look at the vector here. The vector is pointing, the actual arrow is pointing down and right, down and right. Down tells me that it should have a negative y component, and right tells me that it should have a positive x component. So make sure you get this negative sign in there, which you have to put in there yourself because it's pointing downward. Okay. All right. So there's my red solution. The components are Vx. Let me just write that a little bit neater because the signs might be hard to read. So Vx is positive 3.2 and Vy is negative 3.8. All right. What if you solve it using the blue triangle? In this triangle, Vx is up here and Vy is over there. Now this time you can see that Vy is actually opposite of the 50-degree angle. So I'm going to have Vy is 5 sine of 50. Instead of cosine of 40, I got sine of 50. And Vx is going to be 5 cosine of 50. So you'll notice, by the way, the sine and the cosine flipped. A lot of students, for reasons I don't fully understand, want to like say that cosine is always going to be the x direction one and sine is always going to be the y direction one, but that's not true. It depends which triangle you're drawing. So that's why it's really important to draw the triangle and know what you're actually solving, because I can't give you just a master formula that always works. It depends on how you set it up. Okay, so I got the same answer for Vx, of course. For Vy, don't forget to put that negative sign in there as we did before. And this becomes minus 3.8. And of course, we get the same answer as expected. So you can use either of these triangles. There's always 2 triangles you can draw. Sometimes one of them will be much more obvious to draw than the other one. In other cases, you know, it might just be a crapshoot of which one you want to draw. But they'll give you the same answer anyway, as long as you understand what you're doing.